Hi everyone, I'm John Ling from Moldex3D. Today I would like to show you how to create a DOE simulation in Moldex3D, which is our new function in Moldex3D 2020. And in order to create a DOE simulation, first we need to have a reference run, which you can see here. And in this reference run, we need to set up all the necessary input as the models, the materials, the process conditions. And when we create a DOE simulations, all the process will based on this, we'll use this run as a reference. And to create the DOE, we can click this icon and there's a new DOE, or we right click on this reference run, they also have a new DOE. And click this one. The DOE wizard will pop out, and in this page we need to set up what is the quality factor, what is the control factor, and what is the label for the control factor. The quality factor means the target, which it means what is the target we expect. For example, I want the warpage smaller as possible. As smaller as possible, I can choose the warpage, the total displacement, as the quality factor. Or I want to have the pressure, injection pressure, as low as possible. I can choose this one as the quality factor. And the goal is smaller better, so I choose smaller. And also we have a smaller better, large better, uniform betters. And if we have more than one quality factor, we can add more here. But usually I only use one quality factor in one DOE simulation. And in this column, we need to set up what is the control factor, which means what is the process setting we want to change in order to get better quality result. And what is the important factor to the feeding pressure? I would say feeding time, melt temperature, and I want to add one more, so I can click here, add one more control factor. I will say the mold temperature also important to the feeding pressure. And the label means how many input how many different input we have in one control factor. I will say 3. In this case, I want to have 3 different input for each control factors. I want to try the double click, we can change the input. I want to try the mold temperature from 40 to 60 degrees. And go next is a summaries. We will list all the combination based on the Taguchi methods. Usually if we have 3 different control factor, each one have 3 different labels, and we might need 81 experiment to find out what is the best combinations. But with Taguchi method, we can just use 9 to find out the optimized combination. And click this one. The program will create all the runs based on the input we gave. Okay, now the program already create 9 rounds, and there's an extra one called optimized round. The process haven't been decided yet. First, the program will finish all the simulation from round 2 to round 10, and then it will based on the Taguchi method to find out optimized process setting for round 11, and it will run the simulation for it. And now we can just choose this one, the DOE, and run the result. Okay, and once the calculation finished, of course we can check all the results in each run. But the most important one in DOE is the last one, is the optimized runs. The process is set up by the program, and also it's based on the Taguchi methods to find out what is the best combinations. And in this result, DOE, we can see what is the input we gave and the summary. After we have a result, you can see here, the run 11, we already have the process for the optimized runs, which is, in this case, 0.5 second as for the feeding time, and the mold temperature is 50 degrees, meal temperature is 240 degrees. And you can see that the feeding pressure is 16 megapascal, is lower than all the testing we have above. And you can now see this combination from run 2 to run 10. Because with Taguchi method, we don't need to do all the experiment, but the Taguchi method still can find the best combination to optimize our target. And in here is it's a quite useful tool. If we are not satisfied with this result, the optimized run, we still can input different control factor to find out if we can receive the better quality. For example, I want to try 0.49 second, and you can see the program will predict what is the pressure, feeding pressure, what is the quality value. Okay. And in here, we also have a response curve. And in the response curve, it shows you which which factor is the most important ones. In this case, I will say the meal temperature is the most important one, because you can see this curve. Once the meal temperature change, the injection pressure just drop a lot compared to the other control factor. And also there's a signal and noise ratio. And the last one is the response surface result. It's a 3D surface results with the quality factor and 2 control factors. We also can change the control factor here. For example, I want to know how the meal temperature and mold temperature change the feeding pressure. I can choose the control factor as a mold temperature and meal temperature and look these pictures. If we want to have a lower feeding pressure, the temperature of mold and meal should be 50 and 240. Okay. Okay, that will be all to use. That will be all to use the DOE. And thank you for your time today. If you have any questions, please leave the message, and we will contact you as soon as possible. Thank you for your time.